Basic electrical engineering. In this video we are going to learn the effect of temperature and resistance and what is temperature coefficient of resistance and derivation of relation between change in resistance and change in temperature and some numerical problems. Let's see what is the effect of temperature and resistance. The resistance is different from metal to material. The resistance of a material changes with change in temperature. The effect of temperature and resistance varied according to type of the material. The resistance of a pure metal increases with increase in temperature. So overall that the resistance of various material is completely depend upon the type of material. Basically, how many types of materials are there? There are solid conductor type, insulator type and semiconductor type. Mainly we know that. And some are alloy type materials are there, electrolyte type of material is there. Depend upon this model, the resistance is varies with temperature. Let's see what will happen. If the resistance of a pure metal means like copper, aluminum, like that, increases with increase in temperature. So what they call, they have positive temperature coefficient of resistance. Next model. Next is what? The resistance of insulators. Next, it decreases with the increase in temperature. Here this material have negative temperature of coefficient. Because of that, it means resistance of that insulators decreases with increase in temperature. So it have negative temperature coefficient. The next model is semiconducting materials. The resistance of semiconducting materials also decreases with increase in temperature. For example, carbon. The hot resistance of carbon is less than the cold resistance. So this type of semiconducting materials also having negative temperature coefficient. So type of the material, this phenomena is change, whether it increase or decrease. Let's see the next model. The resistance of alloy increases with increase in temperature, but it increases in very little, small and irregular. Alloys means example for that, let's say Eureka, manganese, constant, like that type of material. It increases with increase in temperature but a small quantity. Next, the resistance of a electrolyte decreases with increase in temperature. These things also having negative temperature of coefficient. So temperature plays a very much important role. If the temperature increases or decreases, the value of the resistances are changed. Why this happened? This thing is happened because of that. The temperature in a conductor increases, then the vibration in molecule also increases. So what happened? Vibration increases in the molecule, then movement will takes place. So collision, these molecules are moved and collide with each other. So collision of molecules increases. This increase in electrical collision increases the mean free path and thereby decrease average electronic drift velocity. Therefore, the resistance of a conductor increases. In this case of these conducting materials. Okay, overall what we are observed here is change in resistance is different for different type of materials. We observe 5 different type of materials. One thing is pure metals. Next, insulators. Next, semiconductors, alloys, electrolytes. Depend upon this pattern of material, it changes. Resistance of some material increases with increase in temperature. Resistance of some material decreases with increase in temperature. So if it increases, it's called positive temperature coefficient. If it decreases, then it is called negative temperature coefficient of resistance. Let's see first metals. Metals is having what property? It increases with increase in temperature. Since the resistance of metal increases with the increase in temperature, they have positive temperature coefficient of resistance. Here let's see the property of increase of resistance with increase in temperature is known as positive temperature coefficient of resistance. Example for that what? Copper, silver, aluminium. Here let's observe this graph. This resistance versus temperature. It increases when the temperature rise. Here next model. This is what? Next model is semiconductors. Here in this case of semiconductors, the resistance of semiconductors decreases with increase in temperature. Hence this type of materials is having negative temperature coefficient of resistance. Same insulators and semiconductors having this type of property. Let's observe this graph. Here what happened? It decreases with increase in temperature. So this graph is like this. For metal conductors, the resistance increases with increase in temperature. For semiconductors and insulators, this resistance will decreases with increase in temperature. These are the 2 points we are observed up to now. So let's consider the case of metals. Because of that, our conducting materials are belongs to metallic type. So the increase in resistance. If the temperature is increases, the resistance will be increased. That is the point what we are discussed. How much quantity of resistance is increased? Delta R. We represent with the delta R, the increase in resistance. This delta R is directly proportional to the initial resistance of the conductor, and it is directly proportional to the rise in temperature, and it depends on the nature of the material. If this temperature is increases, we can observe the resistance will increase to some value r suffix t. So what is this delta t r? Delta r is, here we are writing this delta r, that is increase in resistance. Increase in resistance is what? First initial resistance and the difference between rise in resistance, RT minus R naught, where RT is the resistance with increase in temperature, R naught is initial resistance value. So delta R is written as R suffix T minus R naught. The difference between this initial and rise in temperature is called this change in extra resistance. It is represented with delta R. Here what we are discussed, the metals we are consider it as a positive quotient of resistance. First see initial conditions. Initial conditions, the resistance at normal condition, at initial condition we called it as R naught at 0 degree centigrade. Then what we will apply? We apply some heat for that. Then it is increased to RT at T degree centigrade. Because of that, the resistance will change at this rise in temperature. Here let's observe what will happen. This is a temperature coefficient of resistance. Hence, the change in resistance is what? The change in rise in temperature of the resistance minus the initial condition of resistance. RT is the temperature resistance, high temperature resistant. R0 is resistance at 0 degrees. This is R0 and RT. So the difference between these two is called what? Delta R, change in resistance. Change in resistance is this point, and change in temperature is delta T is equal to T minus 0 degree centigrade. Now here what we are the properties observe? This delta R is directly proportional to initial resistance. This delta R is directly proportional to initial resistance, and it is directly proportional to temperature. Right? So overall, these are the two equations above the statements considered. It is directly proportional to the resistance, initial condition of the resistance, and directly proportional to this temperature difference. These above these statements considered, then we are getting these two equations. Next, from these two equations we write it as RT minus R naught is directly proportional to R naught into T minus 0 degree centigrade. This is directly proportional relation, no? For this, if we taking the constant and equal it, here K is a constant K. This K is replaced with alpha. So what is this alpha? Alpha is the constant and it is known as temperature coefficient of resistance. So finally what equation we are getting? R2 minus R naught is equal to alpha into R naught T. Here alpha is a temperature coefficient of resistance. This is the final equation we are getting. Here temperature coefficient of resistance alpha may be defined as the ratio of increase in resistance per degree rise of temperature to the original resistance, and its letter is alpha. What is units for that? Its unit is per degree centigrade. So this alpha is coefficient of resistance, and for different materials it have different temperature coefficient of resistance values. For every material it is changed. We are simplified and rearranged this equation. We write it as alpha is equal to RT minus R naught by R naught T. This is the equation we are right. So by observation, what is the alpha? Its property, it is found that the value of alpha itself is not a constant, but it depends on the initial temperature on which the increment in resistance is based. When the increment is based on the resistance. If we consider the base as resistance, then alpha is measured at 0 degrees. Then we called it as alpha naught. If we consider it alpha at any other initial conditions of temperature T degree centigrade, the value of alpha should be remembered for any conductor. Alpha naught has a maximum value. Alpha naught is what? It is the temperature coefficient of resistance measured at 0 degree centigrade. Here, what is this equations? This is a relation between known resistance and unknown resistance in terms of coefficient of resistance. Here, R1 is the resistance of any conductor at T1 degree centigrade, and alpha 1 is a temperature coefficient of resistance. Like that, R2 is the resistance at T2 degrees centigrade. By using these equations, we are solving some numerical problems also. Dividing the values of this R1 and R2, we are getting this relation. Neglecting this alpha square T1, T2, these terms, then finally we are getting the equation. This is the equation we have to remember. It gives a relation between known resistance and unknown resistance in terms of temperature coefficient of resistance. Let's see some problem on this topic of temperature coefficient of resistance. A platinum coil has a resistance of 3.146 ohms at 40 degrees centigrade. And 3.76 ohms at 100 degrees centigrade. Here in this problem they are giving R1 and R2 at T1 and T2. Right? Find the resistance at 0 degree centigrade. This is the question. And they are giving the value of alpha also. The temperature coefficient of resistance at 40 degrees centigrade. We are taking the help of the above relationship. By solving this problem, we are getting the equation as at R100 the equation is this, at R40 the equation is this. We divide these two equations, then we are getting our alpha value, alpha naught value. So our one bit is over. Next, alpha naught is equation for what? This R naught by 1 plus RT into this T. We are getting this R naught value like that. Alpha at 40 degrees. We substitute the value of this. Now we are getting the equation as these values. Right, in this problem. In this problem, R40 and R100 values are given. T1, T2 are given 40 and 100 degrees. The question is the resistance at 0 degree centigrade and alpha value. Another bit is the temperature coefficient of resistance at 40 degrees centigrades. First R1 is R naught into 1 plus alpha naught T. In this equation we are substitute the value of R100 like that. Here the second equation is R40 is equal to R naught into 1 plus T2 into alpha naught. we are having these two equations. Divide these two equations, then we get the value of alpha naught. 50% of our problem is solved. Next, alpha naught value we are getting, right? In this, we are taking this equation 1. In this, we are substitute the value of alpha naught here. In this equation, we are substitute the value of alpha naught as 0.0373, and this R100 also they are given. R100 they are given as what? Some 3 point like that their value given. We substitute all the values, then we are getting the value of here 3.767 is R100 they are given. We are getting the alpha naught value, substituting all those value, then we get the R naught value. So one bit is over. Now what is this alpha at 40 degrees? For this equation is alpha naught by 1 plus t into alpha naught. Substitute the value of alpha naught in this equation. We are getting the value is alpha naught is equal to 1 by 280 per degree centigrade. Here the problem is very simple. This story is completely depend upon these equations. So you have to remember the equations properly. If we know the equation, then just we are substitute the value of the data what they are given. Nothing in that. Next, the resistance. Next problem, the resistance of the field coils with the copper conductor of a dynamo is 120 ohms at 25 degrees centigrade. After working of 6 hours on full load, the resistance of the full coil increases to 140 degrees. Calculate the mean temperature rise of the field coils. Take the temperature coefficient of resistance of the conducting material as 0.0042 at 0 degrees centigrade. This is the problem they are given. Let's T naught be the temperature of the field coils. Right, in that data they are given at 25 degrees. At 25 degrees we are substitute the value of R and T. We are getting this first equation. Like that we are getting the second equation at rise in temperature of this value. We are having these two equations. Then next step is what? After getting the two equation, we are divide these two equations. Then we are getting the value of T. In the question, what the value at initial condition? 25 degrees. But after solving these two equations, we are getting the value of T is 68. What is the difference between temperature rise? The temperature rise minus the initial 25 gives the final 43.8 degrees. This is the answer. It is very simple problem. The question is big but solution is very small. This is very small solution, right? Let's consider another problem. Two coils connected in series having resistance of 600 ohms and 300 ohms and temperature coefficient are of 0.1 percentage and 0.4 percentage at 20 degrees centigrade. Find the resistance of the combination of temperature of 50 degrees centigrade. What is the effective temperature coefficient of this combination? This is a question they are given. They are given as two resistances R1 and R2, and alpha naught and alpha 1 and alpha 2 are also given, and T1 and T2 are the given. So first we are taking the condition of resistance of 600 ohms at 50 degrees centigrade. Okay, we are getting the equation. This is the first equation. Like that, resistance of 300 ohms at 50 degrees centigrade. We are getting the next equation. Total resistance at this combination at 50 degrees centigrade is, add these two. Let's take beta is taken as temperature coefficient of resistance at 0 degrees centigrade. Then the combination resistance at 90 degrees. Substitute the value of the equation. We are getting the values at 0.02. Let's observe this problem. A coil has a resistance of 18 ohms when it means temperature is 20 degrees centigrade, and of 20 ohms when its means temperature is 50 degrees centigrade. Find its mean temperature rise when its resistance is 21 ohms and the surrounding temperature is 15 degrees centigrade. Just read the problem one more time. They are given some R1 and T1 values and R2 and T2 values. In this question, what is the task? Find its mean temperature rise. Here R1 value is 18 is equal to R0 into 1 plus alpha T. T value is at 20. Like that, second equation R2 value also they are given. What is the next step? After getting these two equation, divide one by another equation. Then we are getting our alpha value. What is their question in this? If T degrees centigrade of the temperature of the coil when its resistance is increased to 21 ohms, then 21 is equal to R0 into 1 plus alpha T. Here alpha they are given as 250, 1 by. So divide this equation by the above equation what we are getting. This is a alpha naught we are getting. We are substitute the value of alpha naught value here. That's why T by 150. Alpha is what here? 1 by 250. So we are substitute the equation. So this equation, let's write the equation 1 here. Equation 2. Divide the equation 1 by equation 2. Then we are getting our alpha value. I think up to this you are clear. And what's the next condition? It is at 21 degrees centigrade. Then here this is the third equation. What we are doing here, you are divide the equation 3 by equation 1. Then we are getting the value of this. Right. The value as 25 degrees centigrade. But and the surrounding temperature is what? 15 degrees centigrade in the question they are given. So actually it is 15 degrees centigrade, but due to temperature, resistances, all those things, we are getting the value of 65 degrees. So our rise in temperature minus initial condition gives the delta T. Here the question is asking the delta T. Delta T is equal to T raised minus T naught. So 65 minus 15 gives the 15 degrees is the answer for 50 degrees is the answer for this problem. Here this problem is very simple. Just we are write the equation R naught is equal to 1 RT some RT. Just what is the equation framing? RT is equal to R naught into 1 plus alpha naught T. Like that R2 is also having the same equation. Divide these two equations, then we are getting the alpha value. This is a model mostly we are doing here. Here what is the base of this equation? The base of this equation is RT is equal to R naught into 1 plus alpha T. This is the base of the equation. If it is particular, if in this problem what they are given as R1 and R2 values. So R1 is equal to R naught into 1 plus alpha T1. Like that R2 is equal to R naught into 1 plus alpha T2. Divide these two equations. Simply we are getting the value of alpha naught here. Once we are getting the alpha naught, then we are substituting in this value at 21 degrees centigrade. Then another equation is came here at 21 degrees centigrade. These two equations are at 18 degrees. These two equations are at 20 degrees and 50 degrees centigrade. Finally, they are given this condition. We have to find at this condition. So, at 21 degrees and 50 degrees, we are solve this. Finally, our temperature rises this much. These are the models. These are having the same type of solutions. In this problem, they are generally asked to find the value of alpha. Otherwise, delta T, temperature rise, or change in resistance, delta R. These are the models we are observed here from the problems. Okay, our first model is about what? Here they are asking alpha naught and rise. This is the first model. And second model, just rise in temperature or rise in resistance or change in resistance, like that. Okay. By seeing this, this is a compulsory problem we are getting in our first unit. long answer question itself. This is a compulsory, you have to practice these problems from first unit. For first chapter we are getting this type of problems in your exams. Okay, this is the first model. In this first model they are given at R1 and R2 conditions. What is their intention? We have to find the alpha value. For this our routine equation is what? RT is equal to R naught into 1 plus alpha t. Here T is at 100 degrees is one equation, T is at 40 degrees is another equation. After writing this equation, what is our next step? Our next step is we have to divide these two equations. Then we are getting simply our alpha value. In this question they are asking at R naught. So here substitute this value of this alpha naught what we are finding here and T and R100 point that data they are given as 3.77. We substitute all the values, we are getting R naught here. This is one bit. Another bit is the temperature coefficient at 40 degrees. For this formula is alpha naught by 1 plus alpha naught T. Alpha naught by 1 plus alpha naught T. We substitute the values. Simply we are getting the value of this alpha at 40 degrees centigrade. This is a routine question. It comes in your exams. It is a routine question. Here we are using this equation. Hope you understand these models. Like that. In this problem also, they are given two types, 25 degrees and 140 degrees. Okay, in this question means we are getting two equation. After that we have to divide these two equation. Let's see, this is the two equations we are getting at 25 degrees and this equation. We are divide these two equations. Simply we are getting the value of T. We are finding. Here also same model. Here also same. They are given at 20 degrees centigrade and 50 degrees centigrade. They want to value at this 15 degrees centigrade. We are writing equation for this. Let's see. We are writing the equation for this temperature at 18 degrees and temperature at 20 degrees and 50 degrees. After these two equations, what we have to do? We are dividing these two equations. Then we are getting our alpha value is this. After that, we have to substitute the values. So, we are writing at 21 degrees centigrade. They want this. So, divide these two equations. We are getting this value. Temperature rise is 50 degrees centigrade. Right. Okay. These are the problems. So in this video, what we are learned? The effect of temperature of resistance. We are observed different type of materials like metals, semiconductors, insulators, alloys, electrolytes. Some are having positive temperature coefficient of resistance and some are having negative temperature of resistance. Depend upon the nature of the material, it was varied. We are considered here, our topic is for conducting materials. So our conducting materials has having positive coefficient of resistance. Why this changes occurs? Due to increase in temperature, what will happen? The vibration in molecules takes place. Due to that vibration, the molecules start moving and collide with each other. Due to this collision, many free paths thereby increases average electronic drift velocity. Then resistance also increases. The change in resistance is directly proportional to change in temperature. This changes depends completely on the type of resistance. Some resistances are increased with increase in temperature. Some resistances will decrease with increase in temperature. So some are having positive coefficient, some are having negative. Right? These are the examples for our metals. Here see, observe this graph. Here for our metals, the resistance will rise in temperature. For our semiconducting and insulators, it will decreases. These are, that's why this graph is like this. Like this, we are observe our equations. This is the final equation. Every time we are using this equation only. RT is equal to R naught into 1 plus alpha T. Alpha is temperature coefficient of resistance. We are observed the theory. See here theory also. They are taking the values at different temperatures for getting the relation between non-resistance and non-resistance. This in terms of temperature coefficient, we are taking these two equations and divide these two. Finally, this is the answer they are getting. Same theory what we are learned as it is, we are solved problem on this type of theory. This some numerical problem solved. This is the content of this video in continuation. So in continuation to this, the previous videos, our first unit of BW chapter is over. You have to solve some more problems available in your textbook. Thank you and thank you for watching this.